Hai, Assalamualaikum. My name is Izzatul Aisyah binti Muhammad SORANI. My MATRIC number is CN180042. Now I want to present my PSM project that title is Study on Mechanical Properties of Concrete Contain Untreated and Treated Pineapple Leaf Fiber. The first one in my PSM project is an introduction. From the introduction, we can get construction is usually unstable in construction because it's a low cost, easy to use and durability. In a concrete has a characteristic by stronger compression but low tensile, bending and blackness. From editor the fiber, it can manage the weakness. Second, PLF fiber come from the plant that aggregated agriculture waste disposal. Application reduce waste biomass in agriculture with a greater demand. Third, the fundamental change is the fiber are worked on the meter and the height rate of related moisturizer absorption may control the brightness characteristic of the concrete difficult. Fourth, impression is on improvement PLF before editing is to the concrete mixture to reduce initial blackness. This it can help identify the best combination ensure PLF and also immediately booster agriculture and building. In a topic introduction is as a objective. The objective of this project is first to ensure the physical and untreated PLF. Second, to evaluate the mechanical parameter of the treated and untreated PLF. Concrete split tensile strength was used. Third, to compare the tensile strength of the PLF mixture with a concrete to the normal concrete. The next point is a literature review. From the literature review, it can get 6 main points. From the main point is a first is a concrete. From the concrete have a subtopic like types and grade, properties and material. The second main point is agriculture waste. The third main point is pineapple leaf fiber. The subtopic is a Yankee pineapple. The fourth is treatment fiber. The fifth is a laboratory test for the fiber. The subtopic is tensile strength for the fiber. And the last three of the main point is laboratory test for the concrete. The subtopic is lump test, density test, compression strength and slip tensile strength. The third point of this project is a methodology. From the video, you can see the flowchart. The flowchart first is discuss the title of this project, and next, literature review. Third, preparing of material and specimen and scope divide of two method. First is preparation of pineapple leaf fiber. Next, to laboratory the test of PLF. The second method is preparation of specimen concrete. And 2. Laboratory test for the concrete. After finish the preparation of materials, we continue the data collection. After the data collection, we continue the analysis and indication, and lastly, writing study report. Okay, from the methodology have a material. The material used for the project first is a pineapple leaf fiber. From the picture, you can see how to provide the pineapple leaf fiber. Second is a treatment of PLF with a sodium hydroxide and NaOH. From the picture, you can see the show of the pineapple leaf fiber in a solution of NaOH. The third picture is you can see the how concrete measure for the cube and cylinder. Next point is result and discussion. Result and discussion get from the testing for the PLF and a concrete. For the testing PLF, we can get result in a tensile strength for the fiber. From the graph, you can see the average tensile strength versus of the weight of sodium hydroxide. From the graph, we can get the greater tensile strength from the fiber was a 5,830 mpm in a 10%, and the lowest tensile across at a 0%, which is 1,077 mpm, and the risk by a 50 until the 60% between a 5 and 7%. The next result get from the slump test. From the graph, you can see the higher amount of PLF treated with NaOH solution added to the concrete reduced workability and measured by a drop test. Okay, this next result we can get from the testing density test. Okay, from the graph you can see the concrete untreated with a PLF weight less than conventional concrete. In a general, density rise with hydration time and decrease with a PLF content. The next result we get from the composite strength stress. From the graph, you can see the relationship between the composite strength at the 7 day and 28 day versus of the treated PLF added. From the graph, you can get concrete strength and PLF treatment at a various concrete age. But PLF drop 0.3% over the M25, and the smooth texture of the PLF causes consumer to undisturbed concrete meets adhesions. The last result get from the testing slip tensile strength for the cylinder concrete. Okay, from the graph you can see the tensile strength versus of percent treated PLF added. From the graph you can get adding 1.0% PLF to 0.2% PLF increases tensile strength by 70%. However, 0.3% PLF, the decrease is at 81% owing to the small texture of PLF in the concrete, which may reduce the binding quality. Okay, the last topic for this PSM project is conclusion. From this project, conclusion can get is to ensure the quality of standard concrete. PLF treated at a higher tensile percent is used as additive. The smooth texture in a concrete lowers the bonding qualities of the concrete mixture, causing the loss of compression and tensile. The ideal amount of the PLF and PLF treatment in a concrete mixture is a 10% for the Na solution and 0.2% for the PLF treated concrete according to the dishes.
And that's all for me. Thank you.